Welcome to the MTD podcast. Today I'm at the headquarters of Renishaw UK at the new mill site in the heart of the beautiful Cotswolds. I'm Giovanni Albanese, a passionate engineer and a proud member of the MTD team. Today I'm investigating and deep diving into the Renishaw latest innovations, which is Fortis enclosed encoders for the machine tool industry and other harsh environments. I'm joined by three special guests. Firstly, David Payne, a passionate engineer with over 24 years experience at Renishaw. And also, I'm joined and have the pleasure to be joined by Corey Fearon, who's got 23 years experience, I believe, Corey?
Correct,
23
yep.
at Renishaw.
At Renishaw, so officially a mid-termer, I think.
Mid-termer. And I'm also joined by a legend who is Rhys Williams, who's the editor of the MTD publication. Guys, welcome to the MTD podcast.
Thank you.
Hello.
Thanks.
I'm going to start with you, Corey. We've had an absolutely brilliant day today, learning about this new technology and one of the latest innovations from Renishaw. But before we get into the technology and get technical, can you tell us about the product? But what made you bring this new product to the market?
Thanks very much for inviting us to this podcast. So Renishaw has been for several decades a very successful supplier of encoders into a whole variety of applications outside of machine tools. So we're very big in electronics assembly, in semiconductor world, and also sort of general purpose motion control, both linear and rotary. We have had encoders involved in machine tools before now. They've been open encoders and non-contact encoders which are used in rotary applications. And so we decided that we wanted to get involved into this market, which is part of Renishaw's real heartland, and taking that encoder technology and making it suitable for use in these types of applications.
Now, the product was officially launched in 2021, but you started development work 10 years prior to this.
That's right.
What did that entail?
Yeah, so there was a whole chunk of that time. I mean, it seems like such a long period of time, but a whole chunk of it, about half of that time, was based on testing and proving out the technology in real life applications. So in conjunction with partner companies and also on machines ourselves at Renishaw, and then going even further beyond the kind of conditions that are experienced inside a machine tool. So I think it's fair to say that we've never been involved at the same depth of partner company work as we have with the Fortis Encoder. It was so valuable. The feedback we had is we can see it in the product, from everything like the development work we did with the seals to make them more suitable for use in the machine tool applications, in the way that the product addresses the pain points that customers have experienced with competitor products, and also just really tiny minor things. I mean, I can point to the fact that the encoder has got a set-up LED on both ends of the read head, because that was feedback that we had from one particular customer. It's the kind of thing that's so easy to miss yourself and very hard to envisage, and yet somebody who's experienced at doing the installation, they try it out on the machine and just come back to you and say, things like this would really help out. That would make my life easier. And that's the kind of thing we built into this product. So it's a much longer development time than we'd normally expect from encoder. But as a result, we've ended up with a really, really good product with tons of customer feedback. And we're able to say at the time of launch, this really is a very, very good fit for their target applications.
I can tell the passion that you've got for this product and how proud you are of this product, and it's brilliant to kind of learn about it today. David, what were the challenges that you faced when manufacturing and designing this product, and what were you challenged with?
Some of the main challenges that we experienced were discussed with our customers. They came to us, they wanted a new encoder supplier in the market. They wanted longevity on their product. They wanted a product that lasted, that was reliable, and was a different offering from the current offerings in the market. Renishaw had a long history of making open optical encoders, as Corey mentioned, but we understood that the customers wanted a new challenge and a new product that they could use that brought them new experiences.
And by the sounds of it, you certainly have. Reece, bringing you into the podcast, it wasn't long ago that yourself and I visited the Miskin site, the Renishaw Miskin site, and you also visited the Miskin site again recently for the 50th year anniversary. Give me your opinion on the Renishaw technology from an overview perspective.
I think from attending the 50th anniversary in March, what came across from many of the directors was the propensity to continue developing new products all the time. And obviously we've got Fortis, Renishaw Centrals coming out. There's new developments with the active side of things. So there's a lot going on at the moment. And it's great to see a UK company really driving industry forward.
You can certainly see, smell and breathe innovation when you visit this facility. It is just remarkable. What pain points were engineers facing with the old encoder technology, and what solutions have you providing with this new technology?
Yeah, well, it's a very good question. The feedback we had when we first started out on the project, in discussions with partner companies, was that the people love linear scales from the metrology and the process foundation benefits that they provide into a machine. However, they got three major drawbacks. They're very hard to install. It's normally a technician level operation to install these products. They always leak, and when you shake them a bit, they fall apart. And so when we sort of analysed what was out there, it's quite clear to us where that's come about. The fundamental design principles in a lot of the existing encoders are very old. It's not far different from the same products that were being used 40 years ago. So that spirit of innovation at Renishaw that you mentioned there, that's really important, because our bosses always say to us, we're not going to develop me too products, which means I'm not going to develop something that's just exactly the same as everything else. There was something that we did manage to get through that was the same, which is the bolt hole compatibility. And that allows us to be integrated in place of the competitors very easily. But apart from that and the external appearance, inside is completely different, absolutely designed from the ground up to say, how would you approach this problem and what solutions are available with modern technology today, rather than just doing a constant evolvement of what was the case of 40 years ago. And so that's where we've brought something to market which is very different and addresses those fundamental pain points that customers were suffering.
We've produced 3 brilliant videos today, and thanks for your help on them,
Thank you.
Corey. And we've looked at all 3 pain points and how you've solved the solution. But let's move on to the actual applications and highlight how these pain points are solved in these applications. Encoders are not on all machines, are they, David? But they're on probably around 10%, you mentioned, of new machine builds. But they're also being introduced into legacy machines, and they're really lending themselves to automated processes to achieve a stable process and unmanned running. David, can you kind of clarify the kind of applications or typical applications that you would expect encoders on, and what benefits you'll get from using them?
It's really the hard turning and grinding applications where high accuracy and high precision is required, and for applications where high throughput is required, where the savings can really be seen and made.
That's really interesting, and we'll go into that in a bit more detail too. Now, Reece, you have a question about the encoders and
Yes, so we were told earlier that Renishaw's been making encoders for 30 plus years, market leader. But from the optical encoders to the Fortis encoders for harsh environments, how have you evolved from the optical encoders to where we are today with the Fortis? Is it an advancement from the optical encoders, or is it a start from scratch approach? and how have you got to where you are with the Fortis?
Yeah, it's actually a bit of a mixture of both. So the guys who work in the optics design would look at the optical scheme of this and say it's exactly the same as you've got inside our Resolute encoders. The electronics design, if you were to look at the schematics, yeah, it's basically a Resolute encoder inside there as well. However, the challenge is that prior to this, we never made a complete encoder system previously. So you would buy a piece of scale from Renishaw and you would buy a read head from Renishaw as two separate parts. Now with Fortis, those two parts are brought together as an assembly. So things like the lip seal technology was completely new to us. The challenges of sealing up a product against a machine tool environment was completely new to us. So those are the areas where we had to be humble enough to say we did not know what we did not know. And that was where the partner program was so important to us, was to help us discover those areas where we didn't have knowledge and we didn't realize that we didn't have knowledge in those areas. And so a machine tool environment is completely different to what we've dealt with before. I mean, if you look at the semiconductor world, we do products at the complete opposite end of the environment in there. So it's, it's incredibly high levels of cleanliness, sometimes vacuum applications as well, ultra high vacuum. And so to go from that to learning about this whole new world for our products was quite a challenge. So we very much involved people from the probe divisions and the tool setters, to get their understanding and their learning about what lessons have they learned over the years, and we're able to apply that into the design of Fortis. So things like the scale inside that encoder is the same. Some of that encoder fundamental technology is the same, but the incarnation was a completely new thing for us, and I think that's where the challenge has really been.
And you mentioned that in the seal technology, you said the product's been 10 years in the making, which may sound like a long time, but you said, was it 5 years to develop the seal technology because you had to develop particular types of material to deal with the harsh environments? That's
absolutely right. It's something which looks so simple, but just on the face of it, you think, okay, I'll just, it's a seal. It's got to keep contamination out. That's where it starts, but that's where, again, that partner company program really helped us, because you were able to, through asking the right questions, find out, okay, what more do you need from a seal? And the feedback was very much the case of people saying, well, they're pretty good, but modern coolants that are coming out are more heavily chlorinated. They're harsher than they've ever been before, and they are just destroying different materials that weren't getting broken up previously. So that chemical challenge was the first aspect to it. The other one is the mechanical wear as well. So machines are moving faster, the throughput is higher, the number of shifts that people are running machines on are more than before, so that the seals undergo a higher level of mechanical wear. There's also people involved in certain industries, so there's more machining of glass, there's more machining of ceramics than there's ever happened before, and those are absolutely horrible in terms of what they produce, in terms like a very aggressive, abrasive swarf that accumulates normally in the worst place possible, which will be right along those lip seals. And so we carried out tests, and some of the things I can point to are a test where we did 14 million cycles of an encoder, where we'd actually rubbed a mixture of iron swarf, which is a really sharp, small kind of abrasive swarf, mixed with carbide grit into the lip seals, and run those for 14 million cycles. We did the same thing as well with corundum powder from grinding machines, just to sort of really give them absolute hell. And at the end of that test, which simulates about 20 years of use, you still got only about half of the lifetime of the seals are worn out in that time. It's really, really impressive how much stronger they are.
It sounds like these encoders are indestructible, and I've also heard a rumour that you throwed one in the lake here at the New Mills site.
That's right. We did. We did that for a social media video. It's a bit of fun. You know, we've obviously done all our proper leak testing to ISO standards, and then we're thinking what would be the hardest thing that you could possibly put the encoder through, and we thought, well, the Renishaw Lake in the depth of winter when it's really, really cold, well below freezing, and threw the encoder in there, left it for 2 days, pulled it out, just wiped it over, bingo, it's got 110% signal, you know, and I wasn't sure if it was going to survive or not. In fact, if I say the popular brand Action Camera did not survive that same test, so it gives you an idea of the durability of the product.
Oh, fantastic! And the material in itself is a credit and a testament to the research and development that you've put into this product, in collaboration with the Air Purge. Tell us about this innovation as well. So there's many innovations within the innovation in itself. So there's the Air Purge that works in collaboration with the sealing to give the product even further longevity, but also flexibility.
Yeah, that's right. The subject of air purges is really quite a hot topic at the moment in this industry. There's some people are promoting the idea to say you can just switch off the air purge, but then in conjunction with that, placing a set of conditions which are not practical upon the customer. And so our approach is to say, well, this doesn't have to be a binary solution. It's not a case of you use an air purge or you don't use an air purge, because actually an air purge brings a lot of benefits to the encoder. It provides a steady stream of dry, clean air into that encoder, which means that if you've got contamination trying to get into the encoder, the air purge will just blow it back out again. It really helps. It's that effective that you can connect it up to the encoder, and if the encoder is flooded, you can actually dry out the inside and drive all the contamination from inside the encoder back out again. It's really a good insurance policy, in effect, for your machine. So we don't want to go against having an air purge, but at the same time, there is a cost to doing that. You have to provide a filter to provide the right cleanliness level of air to the encoder. There's also the cost of the electricity and therefore the carbon footprint as well to that air purge. So the way we've addressed that is those lip seals, they close much tighter around the reed head blade. And that's traditionally something where you've got a bit of a trade-off between how well sealed the product is and how much friction there is in the encoder. And friction is a bad thing when it comes to repeatability and hysteresis. So we had to get this mixture, this balance, just right. And we'd like to feel we've been really successful with this. That sealing, rather than having 7 to 10 litres per minute of air like our competitors do, we only need 2 litres per minute of air. So that right away, you've got a 70% reduction in that cost of the air purge and the carbon footprint of that air purge. Now, the thing that we're promoting to people is to say, well, you don't have to stop there. There are different applications and different demands. So if I was to take the extreme, I would say, okay, if I'm machining ceramic and I've got a process where there's a very large amount of coolant being used in the application, and the encoder is at the bottom of the machine, or the encoder is fully exposed to splashing from the coolant, in those cases, yeah, you probably want to use the best air purge you can. So go for the full 1 bar of air pressure in that case. But if it's an encoder high up in the machine, if it's behind guarding, there are cases where you can say, well, actually, I can use half a bar of pressure or even a quarter of a bar of pressure. I've still got the benefits from that air purge, but I'm now not flowing quite so much air. And so my 70% reduction can now even get up to a level of 91% reduction in carbon footprint. So that is an area where, that's the thing we're promoting with people. It doesn't have to be a binary decision. I'm not going to put undue conditions on our customers of what they can do with our products, but I want people to engage in a conversation so that we can come up with a set of conditions which are going to suit people. And it's literally as simple as saying, I'm going to change the position on a dial. And that's the kind of thing we want to do. I don't want people to put themselves in a place where they're going to have early failures on their machine because they've taken a step too far with what they're doing with the air purge.
It's fascinating, and I just want to. I've still got a couple of subjects to discuss in regards to the Fortis technology. But before I do, how does it work in combination with other Renishaw products, David?
Well, as Corey explained in the videos earlier today, it forms part of the base of what we call the Renishaw process pyramid, whereas getting your process right at the start of the process enables you to set the scene for the rest of your machining processes and quality control. And the Fortis Encoder is part of that by enabling accurate feedback, less scrap, higher precision in a dirty, wet environment.
So it all works completely hand in hand, harmoniously.
Exactly. This is a stage we talk about process foundation. So it's providing a stable environment in which the process will take place. So things like probing becomes, you increase the validity of the probe positions that you're capturing. The same as well with tool setting. It's actually, if you get that process foundation right, then the next levels above help you to achieve even more from your production processes.
Sorry, Reese.
I was going to say, this process foundation, you embed this throughout the company. You've got huge manufacturing sites throughout the UK. So in all of your sites, you've got maybe hundreds of machine tools.
Yeah.
Has the Fortis been installed on all of your machine tools?
We are buying machines now which are being fitted with Fortis encoders. So we have got that process underway. So when we buy new machines now, the Fortis is specified on there. And it's specified for two reasons. One's a commercial one, because obviously, there's some accounts where you kind of keep on knocking on that door and people say, well, all my engineers are a bit busy right now, they can't take that. Well, there's nothing quite like buying a bunch of machines to help people decide to test your product. And so there's that side of things. But there's also, it's not just something we're telling other people. This is what we firmly believe ourselves. We understand the benefits, not just as a manufacturer, not just from the performance of the machine, but also that lifetime experience that you have with the encoder.
I think that you made a really good point earlier in one of our interviews, Corey, that you're making a good machine better, and you're also enabling the manufacturers and machinists to use their machine tools to their full capabilities. Now, moving on to another innovation of the actual Fortis encoder is the installation, which you kindly let me have a go at. And it is extremely simple, but can you explain, it's not just the installation, but the diagnostics that comes with that too, and the other added benefits, and there are many with this encoder, and you have really revolutionised the encoder industry as far as we can see from today.
Well, Gio, for people who will watch the video, you've installed an encoder in 45 seconds. That's incredible.
I think we take this to exhibitions, and I think the record is around about 13 seconds. So a few more practice runs, and I think you'll get there.
But it was a great experience to kind of see how easy it actually is to install an encoder. But what also stood out was the actual diagnostics as well, with the LED lights either side of the encoder for quick verification, if you like, that the encoder is installed correctly. And can you explain the benefits of this and what we looked at and discussed earlier? For example, if there was a machine tool down due to an encoder, in the past that machine tool may have been down for 2 days, but now with this new technology, you're looking to get that machine back up potentially in hours.
Yeah, that's right. The challenge we set for ourselves is to say, how can we make this product suitable for same-day recovery? And so the intention would be that somebody would report, an end user would report that there's a problem with an encoder to the machine builders, service engineers, and the service engineers would be able to go out, take a look at the machine, identify the problem on the encoder, and it could be there's with the diagnostic information, there's a lot of clues that will give you. If you've got the encoder, it's not set up on one end of axis travel, and it is set up at the other end. That would be a classic alignment issue. It could be that something's banged into the encoder and knocked it out of alignment, in which case it's quite simple for the engineer to just undo the screws and reset the encoder, just as you've seen. It's a really quick and simple thing to do. Or if there is a case where, for whatever reason, the encoder has become flooded, then you can just simply whip off the end cap, pour the coolant or other contamination out of the encoder, clean inside the encoder, put the end cap back on, and just get that encoder back up and running. And it's all same day. You don't have to wait for a replacement. Of course, there's going to be some occasions where, someone's done something and they've damaged an encoder beyond repair. Well, in that case there, you contact Renishaw and we get you the replacement out as fast as we possibly can. But the most scenarios will be solved within that 1 day action period.
So is this completely unique to Renishaw?
It is, yeah. With the work, the experience we've had with competitor products, due to the way they are made, and even they say so themselves, when they have contamination inside, you may as well forget it because of the way it works with their carriages, their wheels, their glass scales. With the Renishaw sealed, because the reed head is sealed within, as Corey explained, you can simply strip it down, remove the seals, all the oil will come out, clean it, and get it back up running much quicker than ever before, and indeed any of your competition.
So, Corey, we've discussed earlier that the new encoders, new Fortis, is solving 3 main pain points that manufacturers are having out there.
Yeah.
We've covered the difficulty in installing encoders, the leak issue, which obviously with the air purge system, the seals. So what about the other issue, which is the shaking and the falling apart, which, this is, like you say, the 3 points, and you work very closely with machine tool manufacturers all around the world.
Yeah.
These are 3 pain points. So tell us more about the issue with encoders falling apart and the vibration and the issues there.
Yeah, that's right. With vibration, there's a few problems that we have to overcome. The first one is the obvious one, that if someone really shakes the encoder too much, releasing an alarm and e-stopping the machine. And so people were explaining to us that can happen in cases where you've put a tool into the wrong location in the carousel, or got a setting completely wrong on the machine. So in those cases, and you've hit the material too hard and removed far too much material, shaking the whole machine, and the encoder stopped working. So that's the extreme scenario. That's something that you saw in the videos today, in the making of the videos today, that we've overcome, and you can shake the encoders as hard as you like. We've not been able to break them, and we would recommend, welcome anyone who who thinks they can try harder and actually break the encoders through vibration. But there's a more subtle effect as well, which many machinists may not have realised was actually an effect of the linear scale, and that comes down to when you're machining the material, particularly with interrupted cutting, particularly with things like high-speed machining of aluminium, you can generate resonance or generate vibration in that machine at a frequency which is very unwelcome for the competitor encoders. In those cases, that vibration couples into the position output of the encoder, and you find that the encoder is shaking around inside and feeding back incorrect data to the controller. Now, that incorrect data means it comes across effectively as a positional jitter. The use in our encoder of tune mass damping means that we can actually avoid that. So any system is going to have a natural frequency. We know exactly what it is for our reed heads, and that's something that we've been able to tune out through the use of tune mass damping. So scenarios which cause competitor products to completely e-stop because they're just not happy at all with the position data they're acquiring, or just give very, very large amounts of jitter, only cause about 1 or 2 microns of jitter on our encoder. And that is just exceptional. I mean, you saw today, levels of 37G of vibration going into the encoder, and the encoder holding position to, like 100 or 200 nanometers in circumstances that just cause the competitors to completely stop working. When we hit the encoder with 75G, the worst we saw was plus or minus a micron of positional error coming from the encoder. It's just absolutely staggering how well that technology works. And it's a big leap forwards that can help people achieve better performance in their machines, even higher throughput as well, because they can use optimum combinations of cutters and speeds and feeds, which may have generated these frequencies that would excite the competitor products. So there's an awful lot there that can come about from as a benefit from the work that we've done on vibration resistance.
I think what fascinated me was in our conversation earlier, you were saying the high-speed machine of aluminium generates a frequency of 400, 700 hertz, roughly. And you were saying that a lot of machines are hitting that frequency very often, and that's causing a lot of issues with encoders and the precision. And it can disrupt your surface finishes, your precision. And for the everyday machinist out there, they don't know that. So they are changing their inserts, their work holding, and they're trying to work out what the issue is, when in fact it could be the encoders.
You're 100% right. And we have had cases where customers have spoken to us, seen the promotions and the work that we've done with the vibration resistance, and said, we've got a challenge for you. Can you help us in this circumstance? And we had some examples of people who were suffering literally several e-stops per week on the machine when they were carrying out an operation. So it was a fly cut operation through aluminium. And in that case there, they changed over to Fortis, and they haven't had a single e-stop. And that's approaching 2 years now for use. So it's just an absolute step change in that level of performance there.
Again, achieving a stable process.
100%, yeah, because that was really important in this case, because it was meant to be a lights-out process. But if you've got several e-stops per week, you can't run a lights-out process when you have that level of interruption.
No, and with the technology, effectively, you're reporting to the machine tool and to the controller what is actually happening, and that is basically what you're doing, isn't it?
Yes.
In a nutshell.
Yeah, that's exactly right. I mean, a term that some people use, I think is really applicable. People talk about direct feedback, and that's the way to look at this. Is a linear scale provides you the direct feedback of exactly what's happening on the machine. But I also want us to make a point as well here to say the use of a linear encoder is not a solution to overcoming the limitations of a bad machine. We cannot make a bad machine good. All we can do is make good machines or great machines better. And that's the thing that we're working on and trying to achieve here.
I think it's a lovely way to conclude this podcast. It's been an absolute pleasure to be with you all today and to learn more about the new technologies that you're always bringing to market. David, any last thoughts?
No, just to say thank you very much. Yeah, we've had a good session today. We were very pleased and proud to present the Fortis Encoder to you guys today, and we hope that it will be a great success in the future.
No, thank you, David. Corey, pleasure today. You've been brilliant. Any last thoughts?
Yeah, thank you very much. It's been a real pleasure. You can tell that I'm really proud of the work that Renishaw has done with this product. I think we've done a great job of it in so many different ways, and it's just a pleasure to be involved in it. And I hope you've enjoyed your time at Renishaw today and seeing the things that we do in the background, and some of the work which maybe just goes unnoticed. We did mention today that perhaps the best outcome that anyone can ever have from a linear scale is they just never even know it's there. They just realise that the machine's just working really nicely.
No, brilliant. Reese?
On a personal note, before today, I didn't realise the importance or the level of importance of encoders in many applications. But today, I think machinists can listen to this podcast and get a better understanding of encoders and the impact they can have on the machining performance, which I think is really, really important.
No, 100%. For anyone listening to this podcast, the MTD podcast, thank you for your time. And if you actually incur any of the problems and pain points that we've touched upon, contact Renishaw to find out more. The MTD podcast.
Thanks for listening to the MTD podcast. If you found value in this episode, please subscribe and leave a rating and review. Find more episodes on mtdcnc.com.